In this video, we'll take a look at a rate problem. And in this problem, we are asked to find the value of x where the rate is the greatest. So the rate of a chemical reaction is given by this form here. And we're asked for what value of x is the rate of the reaction the greatest. Well, now, this is the rate of the reaction. And so if we're looking at when it's going to be the greatest, we got to look at the derivative of it, which means we need to look at the second derivative. And that is equal to the derivative of the first times the second. And so we have k times q aught minus x plus the derivative of the second, which is -1 times the first, which is kx. Okay, so if we just kind of clean this up a little bit, kq aught minus kx, which gives us k q aught minus 2x. And so now setting that equal to 0 because we want to find out the maximum. Okay, so now we actually know that this is going to be a maximum if you look at if you just take a look at the original equation, it's going to have a negative x squared, and so this is going to have to be the maximum. It's the only possibility. So if we do this, then all we have to do is divide both sides by k, and so that leaves us with 0 is equal to q naught minus 2x. Subtracting by q gives us a negative q aught is equal to negative 2x. Dividing by 2, or negative 2, gives us q aught over 2 is equal to x. And so this is the value of x that will make that rate of that chemical reaction the greatest. And so here is a case where we didn't have to have a supplementary equation in order to kind of guide what we needed to do. So this is not necessarily normal. These optimization problems usually require some kind of an outside assistance.